Okay, let's have a brief recap on whatever we have done on SHM. The equation of simple harmonic motion, obviously mean position x equal to 0, x equal to a sin omega t plus phi, velocity differentiate x with respect to t, a omega cos omega t plus phi. If you simplify it, you get omega root over s square minus x square, and acceleration is dv dt minus omega square a. Just go through this derivation and try it on your own. Now next we will look at some cases of simple harmonic motion and find out their time periods. So this deal one by one. See this case 1. Say there is a fixed wall, and on smooth floor this is a spring and a block of mass m. Okay. Now what we have done is we have stretched the spring or just displaced by the way, now the block is at rest, spring is at its natural length. So this is obviously the mean position or equilibrium position of the particle of the block. So if you stretch it by x, if you displace the block by x, then the spring is stretched by distance x. So then spring will apply a force in this direction kx. As the force is opposite to the direction of displacement, so we will write F equal to minus kx. Now this k, which is the force constant of the spring, which also matches with the k, that constant of simple harmonic motion. So we know in these cases the time period will be 2 pi root over of m by k. Next problem. Say I have two springs attached, two springs K1 and K2 and attached to the block. Right now the block is at rest and both the springs are at their natural lengths. So now if you displace the block by x, then what will be the forces in the spring? This spring will push with K2x and this spring will pull with K1x. So the net force F equal to minus of K1 plus K2 times x. So for this the time period will be 2 pi root over of m by K1 plus K2. Now question 3, this is slightly different. If this is a block and the springs are not attached to the block, both the springs are having their ends loose. It's unlike this case where the springs were tied to the blocks. These two ends of the springs are loose. Now if you displace the block by x, now what happens? Now from the mean position, if you displace this block by x, then there will be force due to this spring K2x. Now again, if you displace the spring towards left by x, then the force will be K1x. So once it is K1x, when the block moves towards right, it is K2x. When it moves towards left, it is K1x. So it is a combination of two SHMs. So time period is, so it is half SHM in this direction towards the right and half SHM towards the left. So it will be pi root over m by K2 for the right half plus pi root over m by K1 for the left half. Right. Now comes this problem. Suppose you have a pulley here and a spring of force constant K, and this is a mass m, right? Okay. Just I forgot. Before that, let us solve one more problem. say this is a spring of force constant K and a block of mass m, and their gravity is acting G. Now, what is the time period of this simple harmonic motion? This case, this is problem number I think 4. This will be problem number 4. Okay. What will be time period of this simple harmonic motion? Now, as we will see this case here, gravity plays no role to determine the time period of simple harmonic motion, because say this is the mean position, so already the spring is in stretched condition. Suppose now say x naught is the extension of the spring in equilibrium. So kx naught is equal to mg, right? So here the forces kx naught and mg, they balance each other. Now, from this condition, from mean position, if you pull down the block further by x, so here as you see, x is the displacement of the block from its mean position. Now, what will be the extension in the spring? What will be the forces? Now, the extension in the spring is x plus x naught. So, the force in the spring is k x naught plus x, and obviously mass, due to that mass there is weight mg. So, here at this position, what will be the net force? As the displacement downward, so force, we have to put a minus sign. So, it is minus kx. See, this is actually vector sum of this force and this force. So, mg and kx naught will balance, and we were left out with force kx upwards. So, as displacement x is downward, f equal to minus kx. So, therefore, time period will be again 2 pi root over m by k, right. So, now we can move on to solve this problem. This is a massless pulley. This is a massless pulley, and this is a block, and obviously there is gravity. Now, as we have seen in this problem, gravity does not play any role in determining the time period. So, in all these cases, we can put g as 0 and solve for the time period, because the time period won't depend on g anyway. So, suppose this is gravity free space. So, the spring is not extended, it is at its natural length. Now, if you pull down by x, pull the block down by x, the block was at its mean position, pull it down by x. What is the extension in the spring? It is kx. X. The extension in the spring is x, so the spring force is kx. So, for this pulley, it is kx, and tension at this side also it is kx. So, hence tension acting on the block upwards also it is kx. Now, these are not the real forces, we have put g equal to 0, then only we see these forces. Now, why we put g equal to 0? Because the time period does not depend on g, whether you have g or the space is gravity free, the time period of the simple harmonic motion won't vary with that. That is why we put g equal to 0. Okay. So, we are neglecting g for finding out time period. Okay. By the way, so why are these two tensions equal? Why? In a light pulley, the two tensions have to be equal. As suppose if the tensions are not equal, then what will happen? Suppose this force is larger than this force, then the torque due to this force will be larger than the torque due to this force. So, we will get a non-zero torque, net torque equal to I into alpha, Now that is fine, but the problem is I is equal to 0 in the light pulley. So the torque has to be 0. So for the torque to be 0, tension on both sides has to be same, right. So by the way, so we have seen that as we pull the block down by x from its mean position, the force kx starts acting on the block upwards. So as with due regard to the signs, we have to write F equal to minus kx, hence the time period t equal to 2 pi root over of m by k.